Miss Jody here again with our third video for the history of medicine. And as we're moving along, just a reminder here that I will still be printing out all the labels for the journals that go at the top and keeping your journals going. So please be adding your notes or writing your notes on a half sheet of paper so I can glue them right in there underneath the label when we return. And I have been thinking about creating a little drop box at the center if anybody wants to drive by every couple weeks or something and drop off any of their notes, and I can get those done, and that will give me a head start on some of the journals. And so that might be an option since I'm here every day. Okay, all right, so continue on in the history of medicine. Last video we talked about the scurvy and how they found out that it was lacking the vitamin C on the voyages. And this is another one that's going to be similar. And so what's important to note is as they started to find out about the germs, and we had Robert Koch and we had Louis Pasteur with the germ theory of disease and all the ideas that came about and starting to isolate that with anthrax and the chicken cholera and all those things that we talked about, it did get kind of to a point where everybody thought then every disease is probably caused by a microorganism. And so it was kind of hard to then look anywhere else anytime a disease would come about. And so this story is just like the scurvy one. It really wasn't a microorganism. It was a nutritional, dietary deficiency that caused this particular disease we're going to talk about today. All right, so the storyline under the hidden hunger, which is the title of the chapter. In the 1800s, the Dutch East India Company sent settlers to the Orient. And in the Orient, China, Java, the islands of the Pacific. And I think in our book, it gives us a little map. Let me see if there's a little map in our book that shows the areas from the, that they were sending the settlers. So China, Java, the Pacific Islands there, or the Pacific Islands. And so they were sending settlers, and these settlers were coming down with a problem disease, an unusual disease that was striking them. They would grow weak, they'd have no appetite, their heart would weaken, eventually paralysis would set in, and then eventually death. And this was a real problem. The natives called it beri beri, meaning I cannot. And that makes sense, right? Because once you got so weak and you couldn't do anything, I cannot do anything, as a memory tool. I'm not exactly sure what that word actually meant and what it was referring to, but that would be a good way to remember that word meant I cannot. So a few local people suffered from this particular disease, the beri-beri. I think that's how you pronounce it. But for some reason, it hit the settlers especially hard. So there were people in the local area that had this trouble, but the settlers were just inundated with this problem. In 1885, so this is in the 1800s, it doesn't give us the exact time when they started sending the settlers, but in 1885, officials of the Dutch East India Company began wanting to deal with this problem that was happening with their settlers, and they spoke with Robert Koch. And if you remember Robert Koch and anthrax and the idea, Koch's postulate, where we figured out that the anthrax was actually the problem, and they took it from the diseased animal and put it into the mice, and then from the mice into the other animal, and able to isolate it and see that there was a correlation with that microorganism. Anthraxis bacillus, I think it was. And so Koch was very famous of the time, and so they went to him, and obviously Louis Pasteur, and said, hey, can you help us with this? Koch said he would love to help, but he was too busy with other work he had at home. So he was already working on things and continuing his scientific endeavors. But he did suggest a former student of his, and the former student's name was Christian Elkman. I think they say Elkman in the pronunciation key. And so Christian Elkman, if I'm saying that right. And so this particular young gentleman, in 1886, the officials send him, along with other doctors, to Java to tackle the beri-beri. And so they want to start investigating. Now, this was 10 years after Koch and Pasteur had published their ideas that eventually became unified as the germ theory of disease. And people, like I said, were getting on board with, oh, it's probably a germ, it's probably a microorganism that's doing this, and not really wanting to look anywhere else because it was just this magnificent discovery that those little guys even existed, and then finding out that some of them were doing some harm. I think they then thought that all microorganisms were not good. And now we live in a day where we understand microorganisms are very beneficial to our life, and there are a lot of microorganisms that we need and that live in symbiotic relationship with us. But at this point, them not really understanding it all and then finding some of these microorganisms linked to the diseases, everybody kind of went a little crazy thinking it's always going to be the microorganisms. And of course, this gentleman, being a student of Robert Koch, also thought the same way. All right, so a little background on him. So born August 11th in 1858. It's noted that he died November 5th of 1930. So a nice long life there. So he was a Dutch physician and professor of physiology. And so he was really a good learned man, and he was pursuing his heart's desire here in the being a physician and studying under Robert Koch, obviously. His idea was that all he had to do was find the germ that causes disease and destroy it. And remember how Louis Pasteur and Koch worked? You find the germ, you isolate it, you grow it outside of the body, because remember they would grow it in a medium or something, and then figure out how to weaken it or figure out how to kill it, whatever method, and they would just work on it. And the problem when they came across things like the viruses, like with rabies, there was no way to grow it outside of the body because they had to actually be developed in cells, because viruses don't have their own reproduction methods. They need to hijack that of a cell. But they had a way of doing their work. And so they would find it and use the microscope and analyze the blood. They'd find it, and then they would take it out, and they'd studied it, and then they would figure out how to try to defeat it. So he had that same way of thinking. So that's what he did. He began to investigate at a hospital in Java where the beriberi patients filled the wards. And so these patients they did experiments on. They had expert medical attention for the day. They had clean beds, because obviously this is past the time of when they started realizing that it was important to keep that clean situation. Lister, Semmelweis, all those guys. They had the best food, they thought, and it was the fluffy white rice, and it was rice that had been processed, and it had been like cleaned from the husk, so that the mechanically like put through a I don't know, a sorter kind of thing, and it would clean off the husk, and so the rice was really kind of what they would think of as not contaminated by the brown stuff. So they had all this good food, all this medical attention clean, but there still was this major problem among the settlers. And then when you looked at the native people, they didn't have as many of these problems. He noticed that the natives who didn't have those great conditions, they lived in unsanitary conditions, ate poorly processed foods, which was the brown rice, and didn't seem to get the beriberi. So with this poorly processed foods, obviously they were keeping their food as natural as could be, and they were not removing any of the husk and not making it go through a process of that particular cleaning. And so you would think that these guys would have worse conditions than these guys. So he searched for the germs. He used his microscopes, patients' blood. He analyzed the water they drank, the food they ate, and he could not find the germ. And at that time, that's really where the focus was. It didn't dawn on him that it might not be a germ at the time. Other doctors eventually, they gave up. They ended up leaving Java, all of them, and they sailed back home to Holland. But Christian Elkman, he refused to give up. So he still did some experimenting and trying to figure out what was going on. And so just like we saw with Robert Koch and we saw with Louis Pasteur, when they were on to something, they had to figure it out. And many great scientists of the day are attributed to the discoveries because of that same perseverance that they would have. And it's great when you see that in someone. So he didn't want to give up. And of course, money running low, he did some of his own experiments. So he took blood of a beriberi patient and he injected it into the chickens, thinking, okay, well, maybe that will make it sick, just like Koch's postulate, giving the animal the bacteria from an infected animal. But it did nothing. It wasn't causing them any sickness. And then eventually, as he worked with his chickens, not necessarily just the ones that were injected with the blood, but just all the chickens as a whole, he eventually saw the chickens come down with the beriberi on their own, and then eventually they healed. And so he was curious of that, and he had begun to talk with the cook of the time, and he began to see a tie, because the cook had said, a tie basically with the diet of the chickens, because the cook had said that for a while she had run out of the brown rice and she started giving the chickens the white rice, but then she was reprimanded because the white rice was more expensive, and so she went back to the brown rice. And so there for a time they were really, really healthy. Then they weakened and took on the characteristics of the beriberi, and then they started to be healthy again, which made sense in his mind that during the time that they were eating the white rice, they weakened just like the settlers had weakened and started to have the onsets of this beriberi. So he began to think, what if it was dietary? What if there was something about that white rice? And he was right. He was onto something. So what he did is he did an experiment. He separated the chickens into two categories. Some he would give the brown rice, which was supposed to be thought of as poor quality, not processed at all. And he gave some of them the white rice, which they called the good rice. It was machine polished to remove the brown husk. And in the end, the brown husk, the vitamin that actually is provided by the brown husk, is what was missing in this diet that was deprived of that particular natural vitamin that they didn't realize was so necessary. All right, so he finally realized that then those who were eating the brown rice, the chickens, they were staying healthy. The ones who were eating the white rice, they were not. And so he said, there's a link here. And he began to express his opinion, like all of these doctors that we've studied over the years, and they didn't believe him, and they couldn't believe it would be something like rice. Like, how can you say that the good rice, that's the expensive rice that we're putting all this processing to, is the cause of this? And just like everything, like in Sully's time, Lister, all of them, Louis, Koch, they just can't see it, especially if it's something that would be part of their doing, the good rice, and we eat the expensive rice, and yet that's harming us. So they were not willing to. 6 years passed, they still weren't willing to test this out on these people struggling with this terrible disease. But then 6 years later, when struggling to end an outbreak in the Philippines, they finally decided to try it, and they fed the patients the brown rice, and in 2 months they were well, and the disease was gone. Except 4 patients. There were 4 patients who refused to eat the brown rice. And those 4 patients who refused to eat the brown rice were not healthy. So he obviously got a lot of credit eventually understanding. Now at the time, they didn't know what vitamin it eventually it ends up being thiamine. And that is, I think, B1, 3... if I have it written here. Yes, B1, one of the B vitamins. And but in 1911, the word vitamin ends up being coined, and it's Latin for the word life. And so that's where the vitamin world came about. And so there was a suggestion that there are certain things in our world that we need to maintain our life. And so began the categories of vitamins and minerals. And as we know from the biology and the AP biology, the difference between the vitamin world and the mineral world. So the vitamins obviously being more of, they're both the micronutrients, and we also studied this in health. So the micronutrients, which means you only need a small amount, versus the macronutrients like the lipids and the proteins and all that we talked about. Those are the ones you need a lot more of. But in the micronutrient world, the vitamins and the minerals, the vitamins being the ones that are the organic ones that are coming from the living organisms, and they can be broken down easily, like, heat and air and all that kind of stuff can break those down. But then the mineral world, the minerals being the ones that are inorganic, they're not from the living world. So vitamins organic, minerals inorganic, and the minerals, as they go through their processes, they maintain their, their original structure. So they're a little different in those two categories. And so no one thought, first of all, this wasn't even a thing. Vitamins were not even a thing, so how would they even know? And minerals were probably not understood that our bodies even took in inorganic things like that or needed inorganic things like that. So I understand that they didn't think that that was important, just like in the time with the scurvy. But eventually they realized that. Now in 1929, it said that he was given the Nobel Prize in Medicine. I was trying to think on how old. Okay, 1930. So he died at 1930. So, okay, he died a year later. So he was a little bit older when he got this Nobel Prize, but at least he was recognized for his work in this particular area of saving these settlers and others from this dietary deficiency disorder. So that was the storyline with Christian Eckman. I have to look at it every time, Eckman, to make sure I'm saying it right. And that gentleman was just one story in our chapter. It then went on to talk about another person who also started understanding the role of nutrients and these vitamins and minerals in our health. And that is going to be for this little page. Now I'm going to send you a PDF that has this page and the same exact page, a second one, so that you can do two studies on the dietary deficiency diseases. And so the first one I want you to study, and you'll just fill this out. I started filling out so you can see how it goes, is on the goiter. This is a dietary deficiency disease when you lack iodine. And our chapter continues and tells like the symptoms of this and how it was rediscovered and how they figured it out. And so you can use our book to do this particular one. So I want this one done on this to finish up the chapter of the dietary deficiency world. And then this is just for you to draw a picture of whatever, either the person who discovered it and figured it out, or the vitamin, or and also when it says vitamin or mineral, circle which one, whether it's iodine is a mineral. And still, again, these micronutrients, but still very important to life. And our book gives us some insight on other things and how important the iodine is, in this, at least in the small doses that we need. And then this next one, I thought you could pick one. And so there's a whole bunch of dietary deficiency diseases, but I thought if you picked one and then you could do a little presentation, fill this out for your journal, and then you can maybe we can get together and have an online chat, or you can send me a video of explaining which one you chose and why, and I can share that with the group. But there's so many other dietary deficiency diseases that don't have anything to do with microorganisms. It's just about the health of the our nutritional health, and we know how important that is. So you can do one like iron, which obviously anemia is the dietary deficiency disease. I listed out a few just so I could remember to share with you, but let's see, if you have niacin, the B3, you can have problems with how do you say it? Pellagra? I forget how you say it, but it starts with a P, pellagra, something like that. Obviously, vitamin C is one of these, but we've already studied that one, so don't do that one. Thiamine is the one that we just studied with beriberi. Don't do that one. Selenium, you can have Keshan disease, calcium, osteoporosis, rickets, tetany, zinc problems. You can have growth deficiencies. And so you can look up whichever dietary deficiency disease that you want to study, figure out whether it's vitamin or mineral, give me some symptoms, some details of the discovery, and then we'll have a little oral presentation of that. So, and if we decide not to do it on video, if we are able to get back in May, I'm hoping, then we could all share our dietary, which ones we chose. But that way everybody's doing their own study on a particular dietary deficiency disease. Okay? All right, so continue on and make sure you're finishing your questions at the end, which those are so easy. And then next video we'll continue on. And let's see, how many of these do we have? We have a little bit more to go on this, but they're pretty easy, so we should be able to get that done. And I'm just doing one per session and putting them all in order, and you can just do them as you go along.